These are the notes for day 2 of section 11.1 for college algebra. We're looking at summation notation. Does this symbol look familiar to you from last year? Anybody remember what it's called? That's a Greek letter called sigma. All right, it's the symbol we use for summing things. So we've been talking about a sequence of numbers, just a list of numbers. This is what we would use if we want you to add them all together. Okay, so it's called summation notation. A couple things to remember from last year. There's a variable that's used here called the index of summation, and it is used in your formula as well. Okay, so that letter really can be anything. It can be any letter, but it should match. So whatever you choose to use at the bottom of our sigma here should also be the letter that's used in your formula. The number at the bottom, in this case a 1, that is your lower limit of summation, okay, your lower limit. The n on the top is your upper limit. And that's basically giving you a guideline of start here and end here. Okay, we want to add all the terms from this one to this one. Okay, and then in this position where you have the little a sub I, that's going to be some kind of formula that they're asking you to use to create your numbers. Okay, all right, for our first example here, we are summing using this formula, I squared plus 1, and how many numbers are we going to be summing up? Why? Yeah, we're starting with a 1 here, and we're going to stop when we get to 6. Okay, so what I always do is I list those numbers on the top. This one starts with a 1. You'll notice in our next example, you don't have to start at 1. Okay, so whatever they tell you to start with, we'll have 1, 2, 3, 4, 5, and 6. We need to find those 6 terms that we then would add together. Okay, so our first one, it basically just says plug a 1 in for I. Okay, we're going to plug a 1 in there. We get 1 squared plus a 1, which is what? 2. Okay, so our first number is a 2. Then we're going to plug a 2 in there. 2 squared plus 1, which gives us 5. Yep. And then 3 squared plus 1. What do we get? 3 squared plus 1. 10. 4 squared plus 1. 17. 5 squared plus 1. 26. 6 squared plus 1. 37. And the sigma notation there tells me I really want to add all these numbers up. All right, so do that in your head. Grab a calculator if you want. This one's not too bad. 2 plus 5 is 7. 7 plus 10 is 17. 17 and 17 is 34. 34 and 26 is 60 plus another 37. We get a total of 97. Yes? All right. Our second one says this time our lower limit is a 4 and our upper limit is a 7. So we're going to list the numbers 4, 5, 6, and 7. All right, we need to find each of those terms. And notice our formula says take -2 to the k power and then subtract 5. Now be careful here. What happens when you take a negative number to an odd power? It's still negative. If you take a negative number to an even power, it becomes positive. Okay, so if you're going to grab a calculator or anything, watch how you're typing that in. So -2 to the 4th power minus 5. What is -2 to the 4th? Okay, 16 minus 5 would be 11. Our first number is going to be an 11. Our second number, we're plugging a 5 in. So -2 to the 5th power minus 5. Well, what's -2 to the 5th power? -2 to the 5th. Okay, so -32 minus 5 more. -37. Okay. Plugging a 6 in, we have -2 to the 6th power minus 5. So we said negative 2 to the 5th was negative 32. Times it by another negative 2, and we get 64 minus 5, 59. All right. And then the last one, negative 2 to the 7th minus 5. Well, we just have to times this by another negative 2. What's 64 times negative 2? Negative 128 minus 5 more. Okay, now we need to add those up. All right, go ahead and do that. What are we getting? Anybody? Okay. All right, so negative 100. Looking at example C. We're starting with what number? 3. We're stopping with 9. All right, so let's list 3, 4, 5, 6, 7, 8, 9. What's our formula, though? The formula is just a constant, just a plain 4. There is no place to plug in our 3, 4, 5, 6, 7, 8, 9. Every one of our terms is just going to be a 4. All right? Well, how many 4s do we have? How many 4s is that? How many? 7, yeah. So 7 times 4 is 28. The sum of that would be 28. All right, I'm going to pause the video. You guys in your groups try part D. So let's check what you have. We have numbers from 1 to 4. And it says our formula is just square those numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. We're adding those up. Yes? Okay. 1 plus 9 is 10, 4 plus 16 is 20, total is 30? Okay. How is the next one different? What? Okay, so we have a quantity that we're squaring, right? We have to do k minus 1 before we square it. We're starting this time with a 2. And we're going up until we hit 5. All right. So plugging in a 2, 2 minus 1 quantity squared, what does that become? 1. Then we have 3 minus 1 quantity squared. We have 4 minus 1 quantity squared. And 5 minus 1 quantity squared. Is that any different than what we just did in the previous one? We're getting the same numbers. Why? These look different. Our two formulas here. Both of them involve squaring. Okay. The first one says start with a 1 and stop at a 4 and just square those numbers. The second one says start with a 2 and go to a 5, but you're going to be subtracting 1 before you square it. Well, if we subtract 1 before we square it, instead of 2 to 5, we're really down to 1 to 4. Does that make sense? Why it's coming out the same? Okay. All right, so same answers. We start 1 higher in second example, but have to subtract a 1. All right, so we're basically back to where we started. What you have on the bottom of the page here are a couple summation rules. There are others, but these are the ones you might see in what we're going to do. The first one here, we already had an example of this. On our previous page, we were summing just a 4. Remember that one? And every number in our list was a 4. And we said, well, we don't have to add 4 plus 4 plus 4 all these times. We can just say, how many 4s do I have? And use multiplication. So that's what this is saying. If I'm going to sum just a constant, I just have to figure out how many of those am I adding up and multiply that number times the constant. Our second rule says if there is a constant times some formula for a term, we can sum the terms here and then just take that answer times the constant instead of multiplying the constant to every single one first. Okay? And then the last rule says if we are summing in our formula 2 separate expressions, we can sum each expression alone and then add those totals together. Okay? All right, the last couple that we're going to look at. We are giving you the list of numbers this time, and we're asking you to go back and tell me what was that sigma notation, that summation notation going to look like. Okay? So for the first one, I think it's always helpful to label your terms based on their position. This is my first one, second one, third one, fourth one, etc. So what are you doing to that position number that I just wrote to get the number in my list? We're just squaring it. So the formula is just take the number and square it. All right, so our summation symbol, and again, we can pick whatever letter we want. All right, I'm going to use an I. I'm just taking I and squaring it. But now I have to tell the person looking at this what numbers are being squared. We are starting by squaring a 1, and we're ending with squaring a 9. So that would be my upper limit. Does that make sense? Okay. The next one is a little more complicated because of the fractions, but they are giving us a formula at the end. So let's see why that formula works. They're saying we can take 1 divided by 2 to the n minus 1 power. So let's think of the bottom, the denominators, as powers of 2. 8 is 2 to the third. So we have 1 over 2 cubed. 4 would be 2 squared, so 1 over 2 squared. 1/2 would be 1 over 2 to the first. What would the next one be? If you follow the pattern, we had a 3, then a 2, then a 1. Next would be 0. Is 1 over 2 to the 0 the same as a 1? Yeah, anything to the 0 power is 1. 1 divided by 1 is 1. So we're really seeing that the denominator is 2 to a power. Now, how does that power relate to the position it was in? This was my first number, my second number, my third number, my fourth number. My power is 1 lower. That's where this n minus 1 power comes in. We have to take our n value and subtract 1 from it. Okay? So the 8th term in my list would really be 1 over 2 to the 7th. Okay? So what's nice about this is they're kind of giving me the formula I need. So in my summation notation, my formula is 1 over 2. And I'm going to use an I again. Okay? I minus 1. I'm starting with I being 1, right? I'm starting with the first number, I being a 1. And how far do I go? What was plugged in for I on this last term they gave me? What? N. So I'm going to sum up to n of them. Okay? So they haven't given me a specified ending point. All right, last one. We have a plus a times r plus a times r squared plus a times r cubed. What would be the power of r in the very first one? Yeah, I can write this as a times r to the 0. R to the 0 is just a 1. It's going to turn into this a that they gave me. But it's going to allow me to see my pattern. Okay, now we know our summation symbol. We know we are starting, we want to make this easy, we're starting with a 1. Okay, first term, second term, third term, fourth term, etc. So I'm going to start with I being 1. What's the rule that I'm following? What formula would I put in here? A times r to the I minus 1, because again, we're off by 1, right? Our power is 1 smaller than its position. So I minus 1. Then how far do I go? What's my upper limit? If this has to be 1 smaller, it has to be the 15th term. So I'm summing from 1 to 15. Yes? Okay. Now, could I have just as easily said I'm going to go from 0 to 14, and then my power here would not be an I minus 1, just an I? Would that have worked? Okay. So assignment, you guys started this yesterday and you went up to what? Did you do 2 to 30? To 28? Okay. So you're going to do 30 to 60 evens to finish it up?